Namaste and Shanu Shanarthi to all. Today I am going to discuss first chapter from class 10, that is the real numbers. Before going to start real numbers directly, I would like to share one thought, that is life is a mathematics equation. In order to gain the most, you have to know how to convert negatives into positives. I will repeat. Life is a mathematics equation. In order to gain the most, you have to know how to convert negatives into positives. By saying this, I would like to start your real numbers. Dear students, in your previous class and in your junior class also, you have learned so many types of numbers. Now, we have to learn brief introduction about numbers. A number is a mathematical object used in counting and measuring. Numerals or numbers are often used for labels, for ordering serial numbers, and for codes like ISBNs. In mathematics, the definition of number has been extended over the years to include such numbers as zero, negative numbers, rational numbers, irrational numbers, and complex numbers. Now we have to discuss some types of numbers. First type of number, usually you know, natural numbers. What are natural numbers? Natural numbers are nothing but what? All counting numbers from 1. They are denoted by capital N. Example 1, 2, 3, 4, 5, 6, etc. Next type of number, whole numbers. Whole numbers are the set of numbers that include 0 plus the set of natural numbers. 0 and natural numbers are called whole numbers. Whole numbers are denoted by capital W. Next, integers. An integer is a whole number, not a fractional number, that can be positive, negative, or 0. It is denoted by capital Z. Here example given, Z is equal to dot 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 given here. It is nothing but what? Infinite number of negative numbers. Next also last dot is given, that is nothing but what? Infinite positive numbers. Negative numbers and whole numbers. See, from 0 to right side whole numbers and 0 to left side negative numbers. Negative numbers and whole numbers together are called integers. Next, rational numbers. Rational numbers are any numbers that can be expressed in the form of a by b, where a and b are integers and b is not equal to 0. Why b is not equal to 0? Because if b is equal to 0, the denominator becomes 0. If denominator becomes 0, the number cannot be defined. Such type of numbers are not possible in mathematics. So the condition is what? B is not equal to 0 or remainder is not equal to 0. They can always be expressed by using terminating decimals or repeating decimals. These terms, terminating decimals, non-terminating decimals, already you have learnt in your previous class, but also I will explain later now. Examples for rational numbers are 2 by 3, 6 by 7, 1, 2, etc. Next, irrational numbers. Irrational numbers are any numbers that cannot be expressed as a by b, because rational numbers are nothing but what? The numbers which can be written in the form of a by b. Irrational numbers are nothing but what? They cannot be written in the form of a by b. They are expressed as non-terminating and non-repeating decimals. Decimals that go on forever without repeating a pattern. I will explain those non-terminating, non-repeating decimal expansion next. Example for irrational number 0.343343333, next 4, 3, 3, 3, 3, 4, etc. Here 3 appears after decimal C, first 1 time, next 2 times, next 3 times, next 4 times, and so on. We will continue like. Next 45.86745893 and so on. In these two cases, the decimal expansion is non-terminating and non-repeating. Next example is pi root 2, root 3, root 5, etc. All these are examples for irrational numbers. Next, real numbers. Real numbers consist of all the rational and irrational numbers. The real number system has many subsets: natural numbers, whole numbers, integers. See here in the box given, natural numbers, small box is there. All natural numbers are whole numbers, all whole numbers are integers, all integers are rational numbers. Next, one more part is given, irrational number, including, see, rational and irrational numbers together are called real numbers. Okay. Next, decimal expansion of numbers. A decimal expansion of a number can be either terminating, non-terminating, non-recurring, non-terminating, recurring. These are the three types of decimals already said. Okay. Let us see each of the following briefly. First one, terminating decimal. A decimal expansion in which the remainder becomes 0. Terminating means there is a end. The remainder becomes 0. For example, 54 divided by 9 gives 6 as a quotient, 0 as a remainder. As the remainder is 0, this is a terminating decimal. If the remainder will be 0, that is a terminating decimal. Terminating decimal is always a rational number. It can be written in the form of P by Q. Next, non-terminating, recurring. In this form, when a number is divided by the other, the remainder never becomes 0. Instead, the numbers of the quotient start repeating themselves. Such numbers are classified as rational numbers. For example, this is also a rational number only. Example, 3.7250, 7250, 7250, 7250, etc. In this example, 7250 have started repeating itself. Hence, it is a rational number. It can be expressed in P by Q form. Next one is non-terminating, non-recurring or non-repeating. Recurring means repeating. In this form, when we divide a number by another, remainder never becomes 0 and also the number does not repeat themselves in any specific pattern. If a number is non-terminating and non-repeating, they are always classified as irrational number. For example, 0.10, 100, 100, 1400 and so on does have a pattern, but it is not a fixed length recurring pattern. So the number is irrational. Next, come to Euclid's division lemma. This is the first point in your class. You have to write real numbers, definition of real numbers. After that, write Euclid's division lemma in your classwork. Euclid's division lemma states that before going to statement, what you mean by lemma, it is given here, right side. Lemma is a proven statement. It is nothing but what? Already proved statement used for proving another statement. What is this statement? You have to see now. Euclid's division lemma states that for any two positive integers a and b, there exist integers q and r such that a is equal to bq plus r, where r is greater than or equal to 0 and less than b. This is Euclid's division lemma statement. It is nothing but what? Already you have learnt a is equal to bq plus r is nothing but what? In your previous class you have learnt dividend is equal to divisor into quotient plus remainder. For example, for a is equal to 15 and b is equal to 3, it is proved that 15 can be written as 3 5s are 15. 3 into 5, 15. What is remainder in this case? 0 is a remainder. So here q is 5, b is equal to what? 3 and remainder is equal to 0. Next, Euclid's division algorithm. This also you should write in your classwork. One more word, algorithm. What do you mean by algorithm here? An algorithm is a series of well-defined steps which gives a procedure for solving a type of problem. Sometimes you may get confusion what is algorithm and what is lemma. Lemma is a proven statement, already proved statement to use another statement. Algorithm is a technique to solve type of question. For example, Euclid division algorithm can be used to find the HCF of two numbers. To find the HCF of two numbers, we'll use Euclid's division algorithm. This is a technique to find the highest common factor of two numbers. It can also be used to find some common properties of numbers. To obtain the HCF of two positive integers, say C and D, with C is greater than D, we have to follow the steps below. What are the steps we have to follow? Just I will explain steps here now. Next class I will take one example and I will show how to find HCF by using Euclid's division algorithm. Step number 1. Apply Euclid's division lemma to C and D. So we find whole numbers Q and R such that C is equal to DQ plus R. If R is not equal to 0, it should continue again. Second step. If R is not R equal to 0, you have to stop. If R is not equal to 0, you have to continue. D is the HCF of C and D if R does not equal to 0. Apply the division lemma to D and R. It will be continue. Whenever remainder becomes 0, the last divisor is nothing but what? The highest common factor of the given two numbers. Next class I will take one example and I will explain how to find the highest common factor of two numbers by using Euclid's division algorithm. Up to here you have to watch properly. If you have any doubt, I will discuss in next class. Thank you.